I know.
Blank piece of paper. Have we talked negative exponents?
No.
Let's do that. Right on top, this would be exponents subheading negative. Exponents subheading. Use the big board as well. Who's up on I and the boat chairs?
Maya.
Okay. That's all right. So here we go. See if you can pick this up. Negative exponents. Ladies and gentlemen, they are not your friends. Not your friends. There's only one place, there's only one thing that we use negative exponents that really we should, and that's what we'll get to in a minute here. But let me see if I can tell you where a negative exponent comes from. Okay. There's a little rule. Well, let me do this here. If I have 2 to the 5th power over 2 to the 6th power, and I asked you to simplify that. Okay? Now, what you can do is this. Okay, you could write this out. 2 to the 5th power means what? 5 2's times themselves, right? Correct? 2 to the 5th power. With me on that? 2 to the 6th power is 6 2's times themselves. 1, 2, 3, 4, 5, 6. Now, you don't really want to multiply all that out and then reduce the fraction, simply because you could do what? Yeah, 1 for 1, you can cross off the tops with the bottoms, which would give you boink, 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 boink. This one doesn't have anything to cross off with, so your answer is 1/2, right? That's what it simplifies to. But, see, there's a rule in math that if you have the same 2 bases on top and on bottom, and you have exponents there, okay, you can just simply subtract the exponents and you get the answer to the thing. I should have probably done this first. Let's say I have 10 to the 4th power over 10 to the 3rd power. If I did that out, I'd have 10 times 10 times 10 times 10 over 10 times 10 times 10. And we do the same thing. You can cross off 1 for 1. This cross off with that cross off with that, and I'm left with a 10, which is a 10 to the 1st power, which is what I got. If I would have taken 3 from 4, I get what's left over here, which is that 10 to the 1st power. Well, if I would have done that same thing here with these 2's, and I would have subtracted 6 from 5, I get 2 to the -1 power, because 6 from 5 is -1. Okay. I have more 2's on the bottom than I have on top. So when I take that away, I'm going to have a negative number. I probably should have used 8's or something, because that would maybe make more sense too. Let me do another one. Let's say I have 8 to the 12th power over 8. I'm sorry. Let me change that. Let's have 8 to the 8th power over 8 to the 10th power. By definition, by the power rule of whatever, the division rule of whatever here, when I subtract 10 from 8, I get 10 to the negative, or 8, sorry. I get 8 to the negative 2 power. Because when I take 10 away from 8, I subtract the bottom number from the top number. If I were to do this out mathematically, I would put my 8 8s on top. This is going to be a little long. I should have used some smaller numbers, but I wanted you to see if it's something big. 1, 2, 7, 8. How many 8s on the bottom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can cross them all off, except for what's going to be left? 2 of those on the bottom, right? Okay. Which, if I were doing the math, I'm always left with a 1 on top. What's 8 times 8 on the bottom? 64. So based on that, ladies and gentlemen, here's the whole thing. You don't have to understand anything I did. You just have to know this. 8 to the negative 2 power equals the same thing as 1 over 8 squared, which equals 1 over 64. When you have a negative exponent, what it basically means is you have more of that base on the bottom of the fraction than you had on the top, and you're going to get a fraction out of that. Now, what I want you to understand on this as well, this is where people get mixed up. Negative exponents have nothing to do with whether the number is negative or positive. Okay? Because this is a negative 2 exponent, that does not make this negative. It just tells you that you have more 8s on the bottom than the top. As a matter of fact, let's write this down. This is the only rule you need to figure out is this. To make a negative exponent positive, you move the number and its exponent from the bottom to the top, or vice versa. Have you ever used the word vice versa?
Yeah.
Or do the opposite of what I guess what that is.
I felt very fancy.
And you will see that, I will give you some examples for you to see that there. That means this. 3 to the negative 3 power. Again, makes me sad because negative exponents don't mean anything to you in the real world. They don't make sense. Okay? But I can make this a positive exponent, pretend it's in a fraction form like that, simply by moving the 3 in this exponent to the bottom. This is the same thing as 1 over 3 to the positive 3rd power. If you take the number and its exponent, flip it from top to bottom, the exponent becomes positive. I had to put a 1 up there because I can't read the top of it. Which really means 3 to the negative 3rd power is 1 over, what is 3 times 3 times 3?
27.
27. So 3 to the negative 3rd power is 127. Or 2 to the negative 4th power is the same thing as, it's on top of the fraction, I flip it, move it on the bottom, it becomes 1 over 2 to the 4th power. What is 2 to the 4th power? 2 times 2 times 2 times 2. 4 times 4 is 16. So this becomes 116. Okay. It takes a while to get used to these sort of things. Let me see what they give you. Conversely, ladies and gentlemen, if you see something like this, what would 1 over 7 to the negative 2 power be? First of all, you don't deal with negative exponents. I need to make the negative exponent positive. Kelsey Stone, how am I going to make that negative exponent positive? Wait, you could just read it off to me. You move the number and its exponent from the bottom to the top or vice versa. Where is it starting here? On the bottom. Where do I have to put it to make it positive?
The top.
Top. So this just becomes 7 to the positive 2 power. You don't need a 1 on the bottom because that is, and what is 7 squared? 49. Again, it does not change a number from positive to negative. Are you mesmerized by that screen, or should I? Now, how does this come into play, you ask? Oh wait, no, I can't stop. I gotta give you a couple more. This is where things get. This is one of those places. My favorite saying is math isn't hard, it's just confusing. This would be one of those things that is not hard, but it does get to be confusing. You just have to use the simple rules that we give. So write down this example. If the thing tells you to simplify, which just means make it easier to understand. If I tell you to simplify, and I give you 2x to the negative 1 power, y x squared y to the negative 2 power z. Now you look at that and you go, wow, that is what in the world, that's all sorts of gobbledygook. What in the world does it mean? Like, it means nothing, really. Okay, but the reason why it needs to be simplified is because you have negative exponents, and negative exponents make people sad. And we don't want people to be sad. So the first thing you have to do to simplify it is make the negative exponents positive. How do I make the negative exponents positive, Emily Robbins? Yes, you move the number or the letter and its exponent from either top to bottom or bottom to top. These are all on the top right now. So I am going to make this positive. I need to take it and put it on the bottom. I just move it from here to there. It goes away on top.
And then you put the
Same thing for this one. This one is negative. I need to make it positive because it's making me sad. I take the y to the negative 2 and just put it down there. It becomes y to the positive 2. Now, unfortunately, I'd like to say that you're done, but you're not done because you have x's. You have more than one x and more than one y, and you can simplify that by combining them, putting them together, crossing them out, whatever you want to say. So, for example, here I have an x here and I have an x squared there. What happens if I have x times x here and then x there, Sam?
Then we just have one x.
Right, you need to cross this one. X squared means x times x. So this 1x will cross off with that 1x, but you're still left with an x up here. It gets a little confusing because they got a lot of gobbledygook going on here. What about the y's? I've got one y on top and a y times y on the bottom. What's going to happen? That one y is going to cross off with one of the two y's down there. And then when all the smoke clears, there's no z's to cross off anywhere else. What is actually left after all this is said and or done?
2z and
2x.
Oh,
z. There was an x up there that was kind of hidden. All over y. I mean, it doesn't mean anything. It doesn't make any sense. Well, it makes some sense.
So
that is just all you can do. You don't know answers. You never get just number answers because in order to do that, you have to have equal sign somewhere. And there's no equal sign, so you don't know what anything equals. You just know that this is a math. It's like a sentence fragment in English. You know, it doesn't make any sense. It just is. You just keep it there. Let me give you another one, just because I can sense you're like.
we're loving it.
It's a who?
We're loving it.
You're loving who?
We're loving math.
Loving it every minute of it. Let's say you have this and it says simplify 5m to the negative third m or n squared p over p to the negative 2m n to the negative 5. And you're asked to simplify that. Why I did not put that somewhere else, I don't know. Could have taken this all the way up top. Let's do this, and here again is another one. If you are a sloppy person, this doesn't bode well for you, because you really need to kind of take your time and keep organized, because you'll miss what you want. So what do I have to move where, why, when, and how? You've got a couple negatives, right? Actually 3 of them. I need to move this m to the third down, I need to move this p to the squared up, and I need to move this 10 to the 5th up there. So it's gonna look like this. Let's just rewrite it. The 5 stays up top. The m to the third goes down, right? It gets rid of this. The n squared stays on top. The p stays on top. The p to the -2 moves from the bottom to the top because I need to make that positive. So this becomes p to the +2. The m stays on bottom, and the n to the 5th moves up top. Stop me there if you didn't get it. Anything that had a negative exponent, I moved it from bottom to top and changed the sign of the exponent. Okay. Now it's just a matter of combining what you can. Okay, I don't really have much to do other than I have to put the n squared with the n to the 5th, which is n to the 7th, and the p with the p squared, which is p to the 3rd. And on bottom, I have m cubed and an m, which is m to the 4th. I didn't have to do any crossing off.
Mr.
No!
Chapel band has to go.
Then I can't help you. How many more am I losing from Chapel Man?
Me
7.
element.
Good thing I'm recording this, because we got a little bit more to do. Now, just so you understand this little beautiful gem here. Okay, you go and you guys have some.
Oh, cool.
I think that was now.
Yeah.
Like I said, the only time that you are allowed to keep negative exponents is in, and take out your notes under scientific notation.
Are you gonna post the video on the classroom?
I will.
Okay.
Okay. Sometimes it crashes and works on itself. Who knows how much time we'll have when all is said and done here. We already have scientific notation, right? Yes. Let me do the normal scientific notation so you see where we're at, where we're come from. If you have the number like 3,700,000, the rule in scientific notation is, number 1, make this number between 1 and 10, so the decimal would go where? Where? Yeah. 3.7, because that's a number. You write down the times 10, and then how many places did I move that decimal? 1, 2, 3, 4, 5, 6. And that's your exponent. Okay. And what does that really mean? Well, this is a shorter way of writing this. Why does that work? Because if you take 3.7 and multiply it by 10 to the 6th power, what is 10 to the 6th power? It's a million. It's a 1 with 6 zeros after it. If I were actually to multiply this out, I would get the number I started with, but this is so much easier and so much smaller to work with. That's what you know so far. All right. What we need to work on today is, this is really big numbers. We are now forging into the really small numbers, or the really, 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 really small decimal numbers. Okay. The same rule applies. Step number 1 is you need to move the decimal so that it's between 1 and 10. Which means, where would it go? Lila, where am I going to move my decimal to? Very good. Decimal's gonna end up here, it's gonna be 1.7. Okay. Step number 2 is you are still gonna write down the times 10, that's an important part there. That's not so hard. And then here is the kicker. I still count how many places I moved the decimal, which is gonna be, let's do that. Somebody says 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. However, maybe you can make the deductive leap. It's not going to be 9, it's going to be negative 9. Okay, your exponent will be negative if it is a decimal number. Now, for those of you who want, because inquiring minds want to know why is it negative? Because of this. Remember, if I were making this positive, what would I make? What would I make it? 1 over 10 to the 9th power, right? Well, 1 over 10 to the 9th power is 1 over 1 with how many zeros after it? 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you take 1.7 and multiply it by 1 billionth, you will end up with this same number I started with. So we need negative exponents because that tells you that this is actually a fraction of what it is there. But you don't need really to know this. You just need to know that if it's a decimal number, it's going to be a negative exponent. Congratulations, you are now well schooled in the world of mathematics. Let me give you another one. 0.0054. What is that number in scientific notation? With the decimal, so it's between 1 and 10. Put down times 10. Write your exponent as a negative exponent, and everybody's happy. Lucia would be
5.4 times 10 to the
negative third. Just that easy. Don't get that mixed up for this number. What is 54,000 in scientific notation? It would be 5.4 times 10 to the, no, 4. 1, 2, 3, 4. Negative or negative decimals are, let's see what else is here. So I suppose we should do this too. What if I asked you this? What if I have 6.5 times 10 to the negative 6th power? If I give you that in scientific notation, what would that be in standard form? Which means written out as a decimal, without the times 10 part. Kabar, do you think you're smart enough? Do you think you're just that good?
Yeah.
Maybe, maybe not. What do you got, Rye?
It's 0.00000.
Wait, how many zeros?
5.
0.000065?
Yeah.
You are correct. Okay. Now, a helpful little thing to think about this is this. What number is here? 6. Why did I only put 5 zeros there and not 6? Because one of the spaces got taken up when you move this back one place. So whatever number is negative up there, take one away from it, and that's how many zeros you're going to end up putting there. Because you need, one of those things is going to move because you need to move one place here and then 5 more to get to 6. How about this one? 3 times 10 to the negative 9th power. What would that number be in standard notation? A decimal with how many zeros?
8.
Why 8? Because it started here, the 3 took up 1. 1, 2, 3, 4, 5, 6, 7, 8, and then a 3, sorry. Looking. Sure, I'm gonna give you a little chance at this here. Now, listen to this assignment, because this is quite entertaining. So I have to stop sharing this thing. Where am I at? Stop recording.